Here is another way to describe f dot dr. When I look below here, it says f dot dr equals the integral of p dx plus q dy plus r dz, which equals the integral of p rt dx dt plus qrt dy dt plus r rt dz dt. And what we see here is we see a form that we're actually plugging in rt's in for this function p, q, and r. And what p, q, and r are is they're actually the functions of the vector field. So when I see an integral set up in this form here, I can automatically pull out p, q, and r because those will be the functions of the vector field. So now remember the formula. The integral of f dot dr is actually equal to the integral of f dot r prime t dt. So that's what we're actually looking at here. So we have f, and all we would need here is r prime t. So we need rt to get r prime t. So let's take a look at this problem below. It says evaluate the integral of yz dx xz dy plus xy dz. So this tells me right away what my f, q, and r are. So I'm going to write that up top here. So my f is, or my p is, yz, comma, xz, comma, xy. So there's my f. And now we need rt. And to get rt, we're going to use the segment down below. It says here. It says we're going from 111 to 320. So first we need our direction. So to get our direction is we take the 320 point and we subtract the initial point, which is 111. And then in doing so, I get the vector 2, 1, negative 1. So that's our direction. So our RT then, that gives us the RT. So the RT equals 1, 1, 1 plus T, and then 2, 1, negative 1. And now I'm just going to write this in component form. So that's going to be 2T plus 1, comma, t plus 1, comma, 1 minus t. So there's the form we're used to. So I'm going to write that above. So my RT equals 2t plus 1, comma, t plus 1, comma, 1 minus t. And then now we're going to need our r prime t for this formula as well. So my r prime t is going to be 2, 1, negative 1. So now we have all the components we're going to need to do this integral, or evaluate this integral, I should say. So that's going to be the integral of my f, and that's going to be from yz, comma, xz, comma, xy, dotted 2, 1, negative 1. And then our bounds, we didn't talk about our bounds yet. When we set up our integrals in that way, if I plug in my 0 for t, I'm going to get 1, 1, 1. And then if I plug in 1 in for my t, I'm going to get 2, 3, 2, 0, because 1 minus 1 is 0. So the way I set those up, my t, if I'm talking about 2 points there, is always going to be between 0 and 1. So now what we need to do is look below here. This says PRT. So that means for all of my components of t and my r, I'm going to plug that in for each of those x, y's, and z's in p, q, and then r. That's what that means. All right, so we're just going to plug that in, and I know that this is between 0 and 1 now, dt. All right, so let's do that. So then my y is going to be t plus 1, and my z is going to be 1 minus t, comma, and then for my x, that's going to be 2t plus 1 times my z, which is 1 minus t, and the third one then is going to be x. So that's 2t plus 1, and then my y then is going to be t plus 1. And then I'm going to have, that's my first integral, my first part of my integral. I ran out of room, so I'm going to have to move it. So I'm going to take this, I'm going to move it down here. Definitely a lot more room for this. All right, so then it's going to be dotted with 2, 1, negative 1 dt. All right, so there's our setup. So we're going to go through all these FOILs for each of these, and we get, so there's the expansion of all those in the simplification. So now from 0 to 1, we're just going to do our dot product now. So that means we're just going to multiply each component and add them up. So when I multiply that 2 through here, that's going to be 2 minus 2t. And then this 1 by that second component there. And that's going to be minus t squared. And this is going to be plus t plus 1 added with, now this is going to be negated, so actually the negative 1 times all of those is going to be negative 2t squared minus 3t minus 1 dt. So now we're just going to simplify by combining like terms. So we get 2, 4, negative 6t squared. That's all my t's squareds. Then I have my t's. I have 1t positive and negative 3t's. So that's going to be a minus 2t. And then for the last one, my numbers, I can just see those. So ones cancel and I get a plus 2 dt. And then we can just do some simple integrating here. And that's going to be negative 3t, well, I should say 2t cubed. Negative 2t cubed. And then minus t squared. And then plus 2t from 0 to 1. Which equals, going to plug in my upper bound minus my lower bound. My lower bound is going to result in all zeros. So I'm going to get negative 2, because that's going to be times the 1 cubed. And then minus the 1. And then plus the 2 for the last one here. And then it's really just minus the 0 for all three of those, since they all have t's. And this is going to result in negative 1. So negative 1 is our answer for this one here. But again, we really had to go through and figure out what P was, Q was, and R was for my vector field. And once I had that, I just plug everything in. Now again, just keep in mind here when I'm doing these integrals, since it's dt here, all my variables have to be t's. So if I have any x's, y's, and z's in there, I have to make sure I sub in for my t's using the parameters of our t here. Because this is my x, this is my y, this is my z. So that's really the big deal with these. And being able to decipher, if I have an integral like this, that this is really an f dot r prime t, and not just an integral out of nowhere I'm just integrating. And the line segment 2 should be an indicator that I'm dealing with an RT as well. All right, so there it is. Negative 1's our answer.